Hi Rams, this is Miss Moreau. I am here with your next set of notes today. And what we are going to do today is work through solving two-step equations with models. Okay, and this is what it looks like. And I'm going to show you step by step what it looks like with models and the rules at the same time. All right, so I'm going to probably zoom in a little bit to be able to write on it. Hope you don't mind. All right, so I'm going to look over on the right side here. If you have your notes, great. You can write on them, or you may write it on your paper, but these are your notes for today, okay? So your goal is still to isolate the variable. That is always your goal when you're solving any kind of equation. You want your variable, your letter, all by itself away from everything else, okay? So, first rule is get rid of the constant. Okay, that's this number right here, by creating zero pairs. Do you remember from last year, the zero pairs? So what I do, remember, a zero pair, we saw it as a positive integer and a negative integer that cancel each other. It's like positive 1 and negative 1. They have a sum of 0. Okay, so we want right over here beside my variables to become 0. So if I have a negative integer here, what would I do to get rid of it? Well, I'm going to have to add a positive integer, okay, a positive 1 right here. If I have a negative 1, I'm going to add that positive 1. But my rule says whatever you do to one side of the equal sign, you do it to the other side, okay? Do it to the other side. So if I add one positive integer over here, I'm going to add one positive integer on the right side of the equal sign. Okay, now what happened here, I'm going to change colors slightly. This positive 1 and negative 1, they're going to cancel and they go away. Okay, we are going to split the remaining integers up between the variables, however many variables there are. So what I have left over here is 3x's and 1, 2, 3, 4, 5, 6, 7, 8, 9 positive integers. 3x's equals 9 positive integers. So how many integers would go with each x? Well, I'm going to say these 3. Actually, I wonder if there's I think there's a way I could probably cut these and move it. I just don't know how. I'll learn one of these days. Let me erase that mess there. Okay, there's a way. I just don't know how to do this, so I'll figure it out, okay? But these 3 are going to go with this x. And then I'm going to pick another color here. And these next 3 right here are going to go with this one. And then, let's say we'll go purple. And then these 3 integers right here are going to go to this x. So every x equals what? 3 integers. If I could drag them over there, I'm sure there's a way. I just have to learn how to do it, okay? All right, so that is your rules, and we're going to practice a few more examples like this, okay? All right, so here is our first practice problem. First thing we always want to know is what equation does this represent? So 3x, we have 3 x's here. We have 1, 2, 3, 4, 5 positive integers equals, and then all of these negative ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so what we want to know is what is x? I don't want to know what 3x's are. I want to know 1x equals what? So my first rule was to get rid of these. And how do I do that? Well, these are all positive ones, right? If those are positive ones, what do I add to make them become 0? If I have 5 positive integers, remember last year, well, what do I do to make them zeros? I'm going to have to add 5 negative integers. So I'm going to add a negative here, a negative here, a negative, a negative, and a negative. Well, all of those are going to become 0 pairs. They're all going to go back here and go 1, 2, 3, 4, 5. They're all going to go away, right? 5 negative integers. Well, if I add 5 negatives over here on the left, I'm going to have to add 5 more negatives to the right. Okay? Now, I'm going to erase a little bit of this here, just so that I have a little bit of room and I don't have a bunch of writing in the way, okay? So, I'm going to cancel out some of this right here. There we go. These are gone now, okay? And so, what I have is 3x's equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Well, these are negative 11, sorry. Equals 16, negative 16. So what I could do here is just divide them. These were negatives, right? So I'm going to take these and divide them up between the 3 x's here. All right, so I want to take one. If I divided them up, if I had 16 of these negative integers, I'm going to take, say 5, go to that one, right? Because 5 times 3 is 15. And then I'm going to go 1, 2, 3, 4, 5 of them, go to the second x, and then I'll pick another color here and say 5 of them, go to that last x right there. Oh, and I have a little bit left. I have 1 left over, right? So it would be 5, and then I have to take this last one and divide it up into 3 equal parts, okay? So it would be 5 here, and 5 here, and 5 here, but then this one is split up into 3 equal parts, so it's 5 and 1/3. Okay, that was a little bit of a harder problem to start with, but it's okay. 5 and 1/3. All right, I'm going to clear everything there. All right, we'll go to the next problem. All right, so this one, my equation says 2x plus 4. Remember, if it doesn't have a symbol, then we're going to assume it's a positive one, okay? Equals 3. Well, if I have 4 positives here, what am I going to do? I need to add 4 negatives. 1, 2, 3, 4. And if I add 4 negatives there, I'm going to add 1, 2, 3, 4 over here. Okay, now let's circle our 0 pairs. I don't care. Let's see here. These are 0 pairs here, and they're all going to go away, right? That means everything right here, these 4 positives and 4 negatives are going to go away. I'm going to erase all that here in the middle, so it's out of the way. We show that they went away. Okay, but when I go back over here to the ones on the right, okay, I don't care if these make 0 pairs or not. If they do, then great. If they don't, it's okay. My priority was to get the 0 pairs by those x's. So positive 1 and negative 1 here, they go away. Positive 1 and negative 1, they go away. Positive 1 and negative 1, they go away. What am I left with? I'm left with that last little negative 1 all by itself. Right? I'm left with just this lonely little negative 1 right here. So I'm left with 2x equals negative 1. So what is going to be split? What am I going to do with this negative 1 to put half of it in each x there? That's what I'm going to do, right? Take this one integer, and I get half of it here and half of it here. Here's the thing, though. Be careful. It's a negative 1, so it's negative 1/2 and negative 1/2. So x equals negative 1/2. Okay, these are a little bit tough, but it's okay. All right, here's one more for us. Okay, this equation says negative 4x. Okay, right, 4 negative x's here. And then I have 1, 2, 3, 4, 5, 6, 7, 8 positive integers. So it's plus 8 equals, and then I have 2 negatives over here. Okay, here we go. First thing I do is I'm going to get rid of these with 0 pairs. So if these are positive integers, what am I going to need to add? Negative integers. How many do I add? 8. Because if I have 8 positives, I'm going to need 8 negatives to make them become 0. So I have 8 negative integers right now. Now, whatever happens, whatever I do to one side, I will do to the other. So if I have 8 negatives, I'm going to add 8 negatives over here. 4, 5, 6, 7, 8. Okay, all of these are 0 pairs. They are going to go away. Okay, they are going to go away right there. Now, what do I go back to? I have negative 4x's equals, well, over here I already had 2 negative ones, but I added 8 more. So I have no 0 pairs over here. I just have negative 10. All right, so I'm going to divide these up. Okay, so I'm going to start with 2 in each one. These 2 go to the first one. These 2 go to the next one. These 2 go to that x. And these 2 go to this x. Uh-oh, I have 2 left. What could I do to split them up between the 4 x's there? Well, I'm going to split each one in half. That one, half of it's going to go here, and half of it's going to go here. This one right there, half of it goes here, and half of it goes here. So I had 2 and 1/2 for each one of those. Because remember, I had 2 that went, and then another half. Now, but this says that negative x equals negative 2.5, right? Because these were all negative x's, and these were all negative integers. Well, I don't want to know what negative 2x is. I want to know I don't want to know what negative x is. I want to know what x is. Well, I can divide by negative 1, right? Well, what I really did was kind of divide by negative 4 there. But look, the opposite of these. If negative x is negative 2.5, then positive x is going to be positive 2.5. Okay? A little bit tricky one there for you, okay? All right. All right. And now what we're going to do, we are going to practice these, okay? We're going to match each equation and solution to the correct model, okay? So you're going to have another Google slide where you have the models here. You'll have this equation like this. And what you're going to do is drag an equation. If that was your equation here, you would drag it there. And if that was your answer, you're going to drag it and put it here, okay? All right, Rams, this is going to be great practice for you. That's your next part. That is going to be the assignment that shows us that you understand these models, okay? And it is okay if you draw right on it. Show us how you did this. That's great. I want to see that you understand the models. Tomorrow, we're actually going to move to using the algebraic rules to solve these two-step equations, okay? Thanks, Rams.